Okay, so in the last video, we stopped at the point of explaining all the code. So this code has been uploaded to the Arduino and is currently running, and I have my Arduino plugged in. So what should be happening is over the serial port, we should be seeing values that are being printed. Now in the Arduino interface, what we can do is go to this Tools and Serial Monitor, and it defaults to whatever the Arduino is plugged into, and we can see some values being read. As we can see, each line is either a measurement of the flow rate or a measurement of the pressure differential. Okay, so we're getting these values aren't correct. There's currently nothing plugged into my Arduino, so it's just a bit of random data coming out, depending where the Arduino is sitting on my desk. I get different values, but we can see that we get a flow rate and a pressure difference. Now, how do we actually use these values inside of MATLAB? And that's going to be part of the trick for this assignment, and that's what I'm going to go through. So we're not going to make you work it out completely by yourself. We're going to give you a hand. So I'm going to close this window. I'm going to jump into MATLAB. Now, MATLAB has the ability to also read data from a serial port. Okay, and what we want to do is find out what serial ports we can use. So I found this command before, instr find all, and doing that will tell us what serial ports are available on our computer. So serial port object serial COM3. It's on COM3, it has a baud rate of 9600, and the terminator is just a line feed. Currently, no communication, we're not recording anything, transfer status is idle, and we've got some bytes available. So these are all different things. The more you go, if you go into electrical engineering, a lot of this is going to make a lot more sense. But for right now, what we just need is this COM3, okay? So COM3 is what we want to connect on. So to connect to a serial port, we've got to make a serial object first. And so to do that, I'm going to call my object S, and it equals to serial, and the input to serial will be COM3, okay? So COM3 is the port that we're going to be looking on. If you're on a Mac, it's not going to be as short as COM3. I'm not sure what it is off the top of my head. Same thing if you're running Linux, it'll be quite a lot longer. But yeah, so running this will we'll start a serial port object, okay? Now, a couple of the values changed, but, well, one value changed, the bytes available changed, but that's it for now. So right now, we still can't read what's going on the serial port, okay? What we need to do is actually open the serial port, and to open it, we use the fopen command. So like when we're working with files, we use fopen. So if we use fopen on S and press enter, we don't need to store this value. We just run that because we just otherwise communicate with the S object that we had before. Fantastic. So we've now opened the serial port. So if we wanted to read a line, these functions are the same as if we're going to be reading a file, and that's something that's really useful because when we want to test our data, we'll be using dummy files that are just text files. All right. So to read a line, I'm going to use the fgets function. So fgets of S should return a line to me, and that's what we get. So the answer is 253.62 kPa. All right. Running it again, I get 0 liters per hour. Running again, I get this. So we can see that just repeatedly calling this fgets gets us new values via the serial port. Okay. If we just have a look at our serial port object, we can see that the bytes available is currently full. So because the Arduino is sampling at 1 Hertz, so we're getting a new one every second, and we're not reading all of them. They're currently backed up in a buffer. Okay, so to clear this buffer, go to this previous command, I use flush input. Okay, so now when I fgets of s, it's been flushed, and I look at the s object, with flush the bytes available. So we're going to be looking at what's currently being sent. Okay, so a few hints to help you there. So I'll do that quickly. Bytes available are 22. All right, so that just means we've got one line that's been sent, 22 characters. Okay, and that's all I really wanted to cover in this video. That's how we read the data. We use the same sort of commands that we've used before, so fgets. I believe fscanf also works, so we help fscanf, and just wait for it. Fscanf, read data from a text file. This should also work with the serial port. So if we fscanf of s, this is where we give a formatting string. So the formatting string is generally going to be some integer. So it's going to be an integer if it's the flow rate, or it's going to be a decimal number if it's not. So the last one that I read was a pressure, so the next one should be an integer, and that's liters per hour. So if I do that, I should just be able to store the actual number there. Unsuccessful read, matching failure in format. So I was actually incorrect. I was getting sent through a pressure instead. So if I do it again, there we go, 0 liters per minute. Warning, unsuccessful read, matching failure in format. But that's because we got the decimal point there. All right, so do that again, that works. And I changed that to, I think it's %f, 142.29. Okay, but we missed, I made a mistake there, so if we do that, we get 0. Do this, it should be KPA here instead. There we go, so we got rid of that warning. So that's how we read the data from the serial port, and your program should definitely incorporate these steps. Now when we've finished with the serial object, we should close it. So f close of s. And that's it. So now our serial port is closed and we no longer need it. So those are your first 2 steps, or first couple of helpful videos for your assignment. Okay, so have fun.